So we just finished graphing polynomials that were in intercept form. Now we're going to have our polynomials in standard form, and then we're going to have to get them to intercept form by factoring. So to kind of review that process, let's look at this quadratic in standard form, and we're going to graph this to kind of get back in that mindset. So I look at these three numbers and I can factor out a 3, but because my a term is -3, I want to factor out a -3 instead. You always want to make sure your a value is positive to make factoring easier. So then I'll have x squared, and then here it will be minus 2x minus 8. Because if I'm factoring out a -3, all of my signs will change. So now I'm going to be factoring this. So let's make our x, and we have -2 as our b value, and 1 times -8 is -8. So we need two numbers that multiply to -8 but add to -2. This would be -4 and +2. So then our factors are going to be x minus 4 and x plus 2. Remember, when your a value is 1, you don't need to do the box. So that makes this 0, x equals 4. So I'm going to plot that real quick over here. And this 0, x equals -2. Now, we know that this is a quadratic, but let's pretend we don't know that. Let's just look at our factored form, where we have invisible 1 as our exponent, so we're going to cross the x-axis there, and since our leading coefficient's negative, our right side is pointed downward. So this is going to go down, and we cross and cross. And that's what this will look like. We're just trying to get a general idea of what this will look like. So then our end behavior, as x approaches -infinity, y approaches -infinity, and as x approaches +infinity, y approaches -infinity as well, because both ends are going down. So now let's apply that to this problem down here. So first thing I want to do is I want to look for a GCF. You have -4x to the fifth, +34x to the fourth, and -60x to the third. You can divide each of those numbers by 2, and they all have an x to the third power in common. But because our a term is negative, I want to factor out a -2x to the third. And then I am left with 2x squared minus 17x plus 30. And then I am left to factor this. So let's do our x. So we have -17 as our b value, and 2 times 30 is 60. So two numbers that multiply to +60 but add up to -17, that's going to be -5 and -12. And since our a value was not 1, we have to do our box. In the upper left corner, we're going to have 2x squared. In the lower right corner, we're going to have 30. And then it won't matter where we put -5x and -12x. And just like what we've done before, we look at the first column and see what is the GCF of that first column. That is 2x. We look at the second column and say, what is the GCF of that column? It's a 5. But because our top number is negative, we're going to factor out a -5. And then that leaves 2x times x gives us 2x squared. And -5 times -6 gives us +30. So my factors are going to be x minus 6 and 2x minus 5. But we have to then remember to bring this negative 2x to the third down. So this is my factored form. Now we have to set each part with an x equal to 0. So we look at this, negative 2x to the third equals 0. Well, there's no adding or subtracting. So when we have that, we just get x equals 0. Now you may be thinking, well, why didn't we do that up here when we had that negative 3 out front? See, there's no x with that. It's not negative 3x, it's just negative 3. Down here, it's negative 2x to the third. Because there's an x there, we have a 0 at 0. And you know that because there's no plus or minus. There's no addition or subtraction on the inside. We look at this and say, okay, what makes that 0? Well, that is x equals 6. The next one is a little bit more difficult to see. So let's do 2x minus 5 equals 0. And we'll add 5 to both sides. And we get 2x equals 5. And then we divide by 2, x equals 5 over 2. Or you can make that as 2.5. I think when we graph these, it's easier to make these numbers decimals so you know exactly where they go. 2.5 you know is between 2 and 3. So now I'm going to go ahead and plot these points. So we have 2.5, which is going to be between 2 and 3. We had positive 6, and we had 0. Now if we look at our function, and you could use the standard form one if you want, or you can use a factored one. Let's use a standard form one this time because that's what we did. We did the opposite above. Our leading coefficient's negative 4, so negative means it's going to go down, and this is a 5th degree function, so that means the ends are going to go in opposite directions. So if the right side goes down, the left side must go up. And now we have to figure out, do we cross or bounce at any of these zeros? If we look at our factored form, we have an odd degree, an invisible one which is odd, and an invisible one which is odd as well. So those are all odd degree factors, so we're going to cross at all of these. So that is how our function would look. So then the end behavior, as x approaches negative infinity, so if we look at the left side, the graph is going up, so y approaches positive infinity, and as x approaches infinity, y approaches negative infinity. The right side is going down. All right, on this page, we have this function here, and first thing I notice is that we have an x to the 4th, x squared, and no x at all. So we can't factor out a GCF of x, but we can factor out a GCF of 5, and that leaves us with 4x to the 4th minus 37x squared plus 9. Well, now we're left with this mess, and we haven't factored something like that before. Now, what we're going to do is we're going to factor it kind of like the way that we've been doing factoring before with an x in a box. Now, this thing I'm about to show you only works if we have a 4th power, a 2nd power, and then no x at all. If we had an x to the 1st power or we had an x to the 3rd power with this, we couldn't do what we're about to do right now. So we're going to do the same thing, x, and two numbers that add up to negative 37, but add up to 4 times 9, which is 36. So two numbers that multiply to 36 but add to negative 37, that's negative 1 and negative 36. And then we go and do the box, and the box is going to look slightly different. we're still going to put 4x to the fourth in the upper left, the first term, and we're still going to put 9 in the lower right. What changes is what we're going to write in the other two boxes. Normally we would say negative 1x and negative 36x. What we're going to write instead is negative 1x squared and negative 36x squared. So that's the difference. And again, this only works because we have fourth power, an x to the fourth power, then an x to the second power, and then no x at all. And then we're going to look at the first column and see what is the GCF of that first column. It is just x squared. And then we look at the second column and see what is the GCF of that second column. Well, you can divide both numbers by 9, but because this top number is negative, we're going to do negative 9. And then we say x squared times what gives us 4x to the fourth. That's 4x squared. And then you say negative 9 times negative 1 gives us positive 9. So our factors are going to be x squared minus 9 and 4x squared minus 1. Now you may think that we're done. However, we still have to factor these two things. And you could set them equal to 0 first, and that's what I'll do in this problem is I'll set each of these equal to 0 and solve. And then in the next one, I'll factor it at this stage. But just remember what the question may be asking you. I may ask you only to factor this function. And if I factor it and you solve it, that's not following the directions. So I'm going to show you both ways. So we can do x squared minus 9 equals 0. And we can do 4x squared minus 1 equals 0. Well, the one on the left is pretty straightforward. Add 9 to both sides. And we get x squared equals 9. And then when we square root both sides, we get x equals plus or minus 3. So on my graph, I'm going to put a dot at negative 3 and positive 3. Then we work with the green one. We'll add 1 to both sides. 4x squared equals 1. Divide both sides by 4. X squared equals 1/4. And then I'll square root both sides. And we will get x equals plus or minus, the square root of 1 is 1, and the square root of 4 is 2. So we get plus or minus 1/2. Here and here. So then we have to figure out how does this function look. If we look here, we have a positive leading coefficient, so the right side goes up. And our degree, if we look at the standard form function, the standard form version of it, we have a 4th degree, which means the ends go in the same direction. And we have no repeated zeros. So we're going to cross at all of our x-intercepts. So this one will look like a W. So as x approaches negative infinity, y is going up to positive infinity. And as x approaches infinity, y is approaching infinity as well. So one of the drawbacks of not putting it in factored form is that it's hard to see if we're going to bounce and cross at your x-intercepts. So this is one way to do it. It's a little bit less work, but it's easier to miss your repeated x-intercepts for bouncing and crossing. All right, now in this problem, I see that we have an x to the 5th minus 20x to the 3rd plus 64x. So they all have an x in common, so we can factor that out. We have x to the 4th minus 20x squared plus 64. So now I'm going to factor just this part, like we did above. So let me do my x. So negative 20 and 1 times 64 is 64. So I need two numbers that multiply to 64 but add up to negative 20. That's going to be negative 4 and negative 16. So then we'll do the box. And we'll have x to the fourth and 64. And then we'll have negative 16x squared and negative 4x squared. And just like when we factored before, you could switch the location of these two, and it would still give you the same answer. So then we look at the first column and say, what is the GCF of that first column? It's just x squared. And then we say, what is the GCF of the second column? Well, you can divide both those by 16, but because that top one is negative, it's going to be negative 16. And then we say, okay, x squared times x squared gives you x to the fourth, and negative 16 times negative 4 gives you positive 64. So my factored form, or the next step to my factored form, is x squared minus 4, x squared minus 16. But now we can factor these two parts. And because our a is 1, we don't need to do the box. We can just do the x, and there's no b term. We don't have an x to the first power. So when I do the first one, x squared minus 4, 0 is my b value, negative 4 is my a times c, so negative 2 and positive 2. So that would factor to x minus 2 times x plus 2. Now I'm doing the red one, x, 0, and negative 16, because negative 16 times 1 is negative 16. So then our two numbers will be negative 4 and positive 4. So then x minus 4 times x plus 4. So that's my factored form, and in this form it might be easier to see if we're going to bounce or cross at your x-intercepts. All of these x-intercepts have an invisible 1 for their exponent, so their degree is 1. Now, when we graph these, let's plot all these points. So we have 4, negative 2. Let's write these down because we have 0, 2, and 4, but I want to make sure we write them down. So if we look at x, that means x equals 0. X minus 2 means x equals positive 2. X equals positive 2 means x equals negative 2. X minus 4 gives us x equals 4. And x plus 4 gives us x equals negative 4. So those are our 5 zeros. And this is a fifth degree function with a positive leading coefficient. So the right side is going up, and the left side must go down. And because we don't have any even degree factors, we're going to cross at all of our x-intercepts. So your function will look something like that. And behavior as x approaches negative infinity, y approaches negative infinity, the left side's going down, and as x approaches infinity, y approaches infinity as well. So I hope that this was not too difficult. There were some new factoring techniques that we learned, but they're related to the ones that we did previously. It's just that these problems are a bit longer because there's so much to do. Once we factor it, then we have to graph it, then determine end behavior, and all this stuff like that. So thank you for watching. Make sure you like the video and subscribe.